Hi, welcome to a new session of Circuits and Networks. In today's class, under GATE 2025, we are going to see two problems which are involved with transients and two-port networks, especially with capacitance calculations and Z parameters calculation. So this was separately asked in triple E paper as well as in EC papers for 2 marks. So how to solve this kind of problems and what are the basics we require to solve these problems we are going to see now. So in the first case, you can see the switch S closes at t equal to 0 second, means if the switch is open initially. The time in seconds the capacitor takes to charge to 50 volts is dash. You have to round up to 1 decimal places, and this was asked in GATE 2025 for triple E paper. So from figure 1, initially the switch was open, that is at t equal to 0 minus. We consider the initial conditions as 0 minus condition. The capacitor is charged to a voltage. What is that voltage? You look into this circuit. When you see figure 1a from figure 1, the switch was open and the capacitor 5 farads is charged, so it has to charge to some value. What is that value? On the left hand side you have 10 volts. Okay, on the right you can see there is a 3 ampere flowing to 25 ohms, and this 2 ohms, since here it is open circuit, it becomes short wire because the current value is 0 and 0 multiplied with resistance becomes 0 volts, so it becomes as a short wire. So overall, you are going to get the voltage when you go for a clockwise direction notation minus 100 volts plus VC of 0 minus plus 25 multiplied with this 3 equal to 0. You are going to get the value of voltage as 25 volts. So this is the voltage of the capacitor when the switch was open and the capacitor has reached to its steady state. Right. Now what happens? After t equal to 0, switch is closed, and at t equal to infinity, means what? We have to close the switch and we have to wait for the long duration. Then the capacitor is charged to what value? For this we have a special formula that we are going to see over here. You can see the wire is closed. When the wire is closed and the notation, the short circuit is 25 ohms is shorted, so the value of voltage here you can see directly it is VC of infinity treated as 100 volts. So that is the value of voltage immediately after switch is closed, and we are waiting for the long duration. Now this is the conditions of the voltage across capacitor when the switch was open and immediately after the switch is closed. So these two are the inputs what we have received from this figure 1 by looking into these circuits which are shown in figure 1a, 1b and 1c. Now what is our interest? We know that VC of 0 minus is 25 and this is equal to the VC of 0 plus voltage value, because the voltage across capacitor, it cannot change instantaneously, and the voltage at infinity we received under steady state conditions to be 100 volts. Now the time constant for the RC network, when you look into the figure 1b, you can see here you have 2 ohms and the open circuit is over the capacitor value is 5, so the resistance value is 2 and the capacitor value is 5. This gives us the time constant value as 10 seconds. So this is the time constant of the circuit. Now the time in seconds the capacitor takes to charge 50 volts. This is given by, as I told you, a special formula, VC of t, which is equal to VC of infinity plus VC of 0 plus minus VC of infinity multiplied to the e to the power of minus t by tau. Now this condition arises when we have some voltage across the capacitor, and again we need to calculate the time for a new changed value of voltage across the capacitor. Here it is 50. So this becomes 50 equal to, so the steady state value immediately after the switch is closed, it is 100 plus this e to the power of minus t by tau, it is multiplied with this changed value of voltage from initial and final conditions. So here VC of 0 plus is 25, what we have seen, minus 100, this is the condition for immediately closing of the switch, multiplied this term with e to the power of minus t by 10. Now this equation can further classified as 50 equal to 100. 25 minus 100 becomes 75. This minus becomes minus over here. In fact, 50 equal to 75 to the power of minus t by 10. This gives you the value as 2 by 3 equal to e to the power of minus t by 10. In fact, ln 2 by 3 is equal to minus t by 10. Hence, we get the value of t equal to 4.05 second. That's a very good problem. These kind of problems you can again search in our videos. I'll provide certain links. You please go through the transient problems. Then you can easily understand how the capacitor and inductor behavior changes with the changing of the switching position. Anyhow, the next problem is a two-port network, which is shown over here. It was asked in GATE 2025 for EC paper under 2 marks. You can see the Z parametric matrix of a two-port network relates to a port voltage and port currents with this following equation. The Z parameter matrix with each entry in ohms of the network shown is given by options A, B, C, and D. You have to choose the right option. By looking into the circuit and by looking into the options, I can clearly say that Z11 and Z22 value will be greater than compared to Z12 and Z21. So here, by looking to the options, either A, C, or D will give you an answer, whereas B cannot be a right answer because Z11 and Z22, by looking into the circuit, the value should be greater than Z12 or Z21. So B is not a right option. Anyhow, we'll solve this problem with standard notations of Z parameters given by this equation. And we'll go with the first normal approach, that is a substitution method approach, and then we'll go with the open circuit concept of Z parameters. So first, I'm assuming three loop currents as I1, I2, and I3. I1, I3 in clockwise, I2 in anti-clockwise. With this, I'll apply KVL in loop 1 in clockwise direction. Then I'm going to get minus V1 plus 2I1 plus 2I1 minus I3 equal to 0, which gives you the value of equation V1 equal to 4I1 minus 2I3. And similarly, when you apply KVL in anti-clockwise direction over this loop, you're going to get V2 is equal to 4I2 plus 2I3. And in the middle of the loop, if at all you apply KVL in clockwise direction as shown in the dotted line, then we are going to get the value of I3 is equal to 1 by 3 I1 minus 1 by 3 I2. Equation 3, 2, 1. You can substitute this 3 in 1 and 2. Then you're going to get V1, which is equal to 10 by 3 I1 plus 2 by 3 I2, and V2, which is equal to 2 by 3 I1 plus 10 by 3 I2. With this, the Z parameter networks can be framed from equation 4 and 5 as 10 by 3, 2 by 3, 2 by 3, and 10 by 3. So option A is the right answer. Anyhow, if it was the same problem, you need to solve with a shortcut method. First, you look into this circuit. It is almost in T shape. In middle, you have a delta shape. So here you can get the value of this parameters delta can be converted into a star network by changing delta to star. You can see here you have 2 and here you have 2. So 2 into 2, it becomes 4 divided by 2 plus 2 plus 2, that is 6. So you have 4 by 6. This becomes 2 by 3, 2 by 3, 2 by 3. Now you can change this delta with this star network, and the resistors on left and right will add up to 2 and 2 respectively. Then this is how the circuit looks like. Now you see here 2 plus 2 by 3, 3 into 2 becomes 6, 6 plus 2 becomes 8. So 8 by 3 ohms, 8 by 3 ohms, and in between you have 2 by 3 ohms. When you open circuit second port, that is this V2 with I2, that is treated as port 2, that you open circuit, then it becomes 8 by 3 plus 2 by 3, then it becomes 10 by 3. So that is how you need to look into the other parameters. So you'll get the value directly as 10 by 3, 2 by 3, 2 by 3, and 10 by 3. So this is how you need to sort out the problems under GATE exam analysis. So I hope you like this class. Please share this video among your friends, subscribe to this channel, and please press the bell icon for the future notifications. Thank you.